Hi, welcome to myprojectwhatsapp.com. Project title is SafeStack, automatically patching stack-based buffer overflow vulnerabilities. This project comes under the domain of network security. Buffer overflow attacks still pose a significant threat to the security and availability of today's computer system. Although there are a number of solutions proposed to provide adequate protection against buffer overflow attacks, and most of the existing solutions terminate the vulnerable program when the buffer overflow occurs, effectively rendering the program unavailable. The impact on availability is a serious problem on service-oriented platform. In this paper, we propose a novel system called SafeStack, which can quickly and automatically generate patches to stack-based buffer overflow vulnerabilities and apply the patches without stopping the vulnerable service. The key technique of SafeStack is memory access virtualization, which relocates memory object to selected location. Once an attack is detected, SafeStack identifies the stack object that trigger the stack buffer overflow, generate runtime patches which consist of vulnerability signature, bug triggering buffer, and vulnerability treatments, and apply them to move the stack objects into protected memory areas. SafeStack is designed to learn from attacks, although the application still suffers the first attack. SafeStack can diagnose the vulnerability origin from this attack and generate patches to fix the stack-based buffer overflow vulnerabilities. As a result, the automatically generated SafeStack patches enable the application to survive exploits and continue to process subsequent circuits. Next, I am going to explain the data flow diagram of the process. Start the process, and next data collection. Data collection, we must collect the log file in the process and load the file into the buffer. When they load the file by size is greater than the buffer size, when buffer overflow should be occur. If buffer overflow should be occur, we increment the canary value for identifying the bug triggering buffer in future, and goes to the SafeStack system. In SafeStack system, the main key technique in the SafeStack system is memory access virtualization. Using these techniques, we are going to calculate the new address, and next we relocate the buffer into the new address using the memory access virtualization, and identify the bug triggering buffer using the canary value, and next the patches generation for the bug triggering buffer. In the patch generation page, we are going to report the bug for the bug triggering buffer and apply patches for the bug triggering buffer. Finally, we get the original file after applying patches in the vulnerabilities, and we stop the process. Next, I am going to explain the running procedure of the project. Start the WAMP server, open the NetBeans. These are the package. Inside the package, we first run the title.java. These are the title page of the project. SafeStack, automatically patching stack-based buffer overflow vulnerabilities. Click next. Next, we are going to browse the log file dataset. Click browse. Go to the package. Inside the package, data folder, click dataset.txt file. The dataset file, the log file should be loaded in databases successfully. Next, click view. These are the log file. The canary value should be empty. It means 0 for the all buffers. These are the buffers information. The buffer contains ID, date, time, services, bytes, address, and the content inside the buffer. Click next. Next, we are going to register load the data into the buffer. Get the buffer ID as 101. Get the current date and time. Which services you need to send the data. For example, HTTP. Upload the file into the buffer. Go to the package. Inside the package, choose the sample.txt file. Get the bytes of this file. Get the address as 100. Initialize the canary value as 0. Click process. Request was processed successfully. Go to the buffer information. Get the original file. These are the original file and size of the file is 1258 bytes. And get the buffer file as buffer ID as 101. View the buffer information. The data loss should be occur when we load these data into the buffer. Get the size of the buffer is 50. So the buffer overflow should be occur. So you increment the canary value. Increment the canary value as 1 and go to the SafeStack. View the stack details. These are the stack. We use memory access virtualization to calculate the new address. Click memory access virtualization. Get the buffer ID as 101. Get the base register and index register. It should be valid. Then calculate get the original buffer address and buffer base register as 101. Index register should be 1. Scale factor should be 2. Any number displacement value as 100. From this value we are going to calculate the original address, new address. Go to the next, click next. Insert the buffer relocation ID. Calculate the new address. Click relocate. Buffer was relocated successfully. View now these are the buffer relocation table. Then go to the SafeStack. Next we are going to identify the bug triggering buffer. Get the canary value, get the buffer bug triggering buffer and size of this buffer. Now we are going to identify the bug triggering buffer. Go to the SafeStack. Then we are going to apply generate the patches for the bug triggering buffer. Click patches generation, get the vulnerability signature and bug triggering buffer, and vulnerability treatment should be a buffer relocation ID. Generate the patches was generated successfully. Now we are going to report the bug for the particular vulnerability ID. Click next. Next we are going to manage the batch. Number of patches should be generated. Vulnerability ID should be the same as we are going to calculate it before. Get the current time and we are going to elapse the time for the generated these patches. Click apply. Patches are applied successfully. Get the buffer relocation ID. Now we are going to get the original buffer successfully. Click evaluation. Performance evaluation. Now we are going to calculate. Click time. From using the SafeStack mechanism, we are going to generate the patches in the 54 seconds efficiently when compared to the restarted method. Finally, the conclusion of the project is we present a new system SafeStack which can automatically patch stack-based buffer overflow vulnerabilities. The system focuses on vulnerability originality, that is vulnerability triggering stack buffer. The system first tries to identify the bug triggering stack buffer and smooth them out of the stack to a protected space using a novel memory access virtualization technique. Thank you.